what we're doing today, we're probably can get through this in a day, today's lesson. Now, we're talking about linear equations in two variables. At this point, I don't think there's much new stuff we can cover in this. Because when we talk about a linear equation in two variables, we're talking about a line, x and y. That's it. First thing we're talking about is slope. Linear equation, two variables, y equals mx plus b. Linear because it's a line. And if by letting x equal 0, you obtain this here, that b is the y-intercept. Line crosses the y-axis at y equals b, because that's our y-intercept, where x is 0. And if the slope is positive, it goes up, and if the slope is negative, it goes down. I think at this point that y'all have gone over that so many times, this isn't anything new. M is slope, B is the y-intercept. Rises or falls. Slope-intercept form, y equals mx plus b. And y'all know why they call it the slope-intercept form? Because what's M? Slope. B is the y-intercept, so it's the slope-intercept form. I mean, if you think back to a lot of the stuff, the way that they name formulas or equations in mathematics for what you guys learned in Algebra 2, Geometry, and Algebra 1. Pretty much everything they named it was exactly what it was 100%. They didn't deviate much from what it actually told us. When we have x equals a number, it's a vertical line. It's straight up and down. When we have y equals a number, it is a flat line. And that's it. Do y'all need to see examples of how to sketch a graph a line? Not really, because at this point, I mean, we could type this into a graphing calculator, or, yeah, really, we can just type it into a graphing calculator. For the graphing the TI-84 Plus, we just need to get these in the form of y equals mx plus b. That's going to be the equation of a line. Now, we know it's not going to be linear or a function if this has any power greater than 1 or has anything with y. Then it's not going to be a function. We can still graph it. We can still find its equation. There's still numbers that work with it, because a circle, y squared plus x squared equals r squared, isn't a function. It's a circle, because it doesn't pass the vertical line test. But we still have numbers. We still have equations. We still have stuff we can do with it. Because b is equal to 1, the y-intercept is 0, 1. Moreover, because the slope is 2, the line rises 2 for each unit and moves to the right. We have our flat line. We have the one that's going down. Questions on any of this here? Finding the slope of a line. Well, m is our slope, which is y2 minus y1 over x2 minus x1. We're talking about the change in y over the change in x, or delta y over delta x, because the delta, that triangle, just means change. We're talking about the change in y over the change in x. Or we can say f of delta x minus f of x over delta x minus x. Change in y over change in x. The new x value over the old. F of delta x, again, f of x is just another way to write y. Our new y minus the old y. And that's really it. I mean, I don't think I need to go into finding the slope of a line, do I? Y'all remember how to plug these numbers in. Rise over run. passing through 2 points, we can't, the points have to match up. Whatever y value goes first, its corresponding x has to go first, and vice versa. This is the only one where order matters between midpoint, distance, and slope. Slope's the only one out of the three that order matters through finding the equation of slope. I don't think I need to go through an example of how to find the slope. Would that be a correct assumption? Yeah. Write an equation of a line in two variables. Well, one of the main ones that we use to find the equation of a line is point-slope form. And incidentally, they named it exactly like it is because x1, y1 is a point. M is our slope, so we have slope point-slope form. And we can use this to find the equation of any line because all we need is the point and the slope, and we can find it. Because if they give us the point -1, -2, and the slope of 3, we plug in the x for its spot, the y in its spot, and the slope in its spot. And then we simplify to get the equation of the line. That's it. I think two-point form is the most overcomplicated equation. Well, let me rephrase that. Is the most unnecessarily complicated equation that we can have, or at least that we've covered so far. Because this here is just replacing m. We just plugged the formula for slope in and did this all at once. I think this is too much to try to do all at once, all at the same time. Because realistically, finding the slope is not that hard. Why throw it in the middle of point-slope form to try to just make everything easier? It's not. I don't think it's making it any easier. Some might think that, and that's fine. But I would rather just find slope, plug that value in for m, and then do what we would normally do. All right, parallel and perpendicular lines. We know two lines are parallel if they have the same slope. They're perpendicular if they have the opposite reciprocal. We flip it and change the sign. Perpendicular, we flip it and change the sign. They're going to say that we put it as -1 over m. When we put it in the denominator, it comes back up and flips. So we'll do this one here because this one is sometimes a little more challenging, but not too bad. The first one we'll look at is parallel. Find the slope-intercept form of the equation of the line that passes through 2, -1, and are parallel to and perpendicular to the line 2x minus 3y equals 5. First thing we need to do is find the slope of this line. And the easiest way to do that is to get it into y equals mx plus b form. Bless you. So the first thing we can do is subtract the 2x from both sides. Then what are we going to do next? We're going to divide by -3, yes? Now what are we doing? The whole reason we're doing this is to find what? The slope, yes? So the first one here we would get y, yes, is equal to -2 divided by -3 is 2/3 x, yes? Do we know what the slope is? 2/3, yes? Do we need anything else from this equation? No, right? So does it really matter what 5 divided by -3 is? No, because all I really want is this. I mean, it works out that it is -5/3, but that doesn't matter really. The fact that it now equals y doesn't matter. We just want the slope, because that's the only thing we need from that equation. Because for parallel, our new slope is 2/3. For perpendicular, we change and flip. So for perpendicular, since it was positive, it's now negative. Since it was 2/3, it's now 3/2. All right, we don't even need that anymore. I just need to find the slope. So a lot of times when I'm doing this, especially if they gave it to us in standard form, this here is standard form, I'll really just go about finding the slope. I really don't care about that constant 5. I just want the slope. So I'll more or less ignore the 5 and just work on trying to find the slope. It is nice to know what the equation is, but since we're not graphing it, or because again on the homework I'm not going to make you graph the original equation and the lines perpendicular and parallel to it. Not going to do it. So really, if we were to graph it or they required you to graph it, okay, then this is important because we need it to graph. We're not graphing, so none of that's important at this point. This could all go away. All right. Okay. Questions on this so far? So our point slope form, y minus y1 equals m times x minus x1. So what's our point? 2, -1. Our y value is -1. The slope is 2/3, and the x value is 2. Now a negative and a negative over here make a plus. Now we do need to distribute the 2/3. 2/3 times x is minus 2/3 times 2 is 4/3 because the 2 multiplies with the 2 on top, giving us 4/3. And last but not least, we need to subtract the 1, getting us y by itself is equal to 2/3 x minus. Anybody know what -4/3 minus 1 is? No? It would go up because since it's negative, we're subtracting, it would get a bigger negative. So we'll still have a 3. Or essentially, we're saying -4/3 plus -1. Well, since it's a whole, how many thirds would we have? 3/3? 7. The TI-30XS will do it. You can do -4/3 minus 1, hit enter, and it will give you the fraction. The graphing calculator will do it too, but if it gives it to you as a decimal, if you hit math, the button that says math, M-A-T-H, and hit enter, the first one that pops up is fraction, or F-R-A-C. You hit enter, enter, it should, for most, it'll turn it from a decimal to a fraction. If it's too, I don't like to use the word ugly. If it's either can't do it or quote unquote won't do it, the denominator or numerator, one or both are too big. So something like this here, most likely it's just going to keep it as a decimal. The yellow calculator will do the same. But for most of the stuff that we work with, thirds, not too bad. Because realistically, this is going to come out as 2.6 repeated. Let's see here. No. 2.3 repeated. Because 3 goes into 7 2 whole times, leaving us with a remainder of 1. 1/3 as a decimal is 0.3 repeated. So, just something, if you see a decimal like that or some of the ones of the repeating, those are either 3, 9, 3 or 9 are the constant number going on. 9s are either 1, 2, 3, 4, 5, 6, 7, 8 are the repeated numbers. But questions on this here, or the fact that I just went off on a tangent? So for this other one here, we're doing the same thing, y minus y1. Well, our y1 is still -1. Our slope this time is negative 3/2 times x minus 2. Just like before, the negative and negative make a positive, plus we're going to distribute. Well, we'll get negative 3/2 x. So negative times a negative makes a plus. What's negative 3/2 times 2? Well, 3 times 2 is? Yeah, 6. 6 divided by 2 is 3. Well, the 2 and 2 would cancel, leaving us with 3. And last but not least, we need 2. Subtract 1, telling us y is equal to negative 3/2 x plus 2. That's it. Questions on this here? Questions on anything we've done so far? We kind of like this. I mean, it's just not as bad stuff. Unlike some of the problems yesterday or the day before. Notice in example 4 how the slope-intercept form is used to obtain information about the graph of a line, whereas the point-slope form is used to write the equation of a line. Yeah, they can be used in different ways. I mean, we can use this change or this rate of change in kind of, again, real-world problems. This one here is closer to a real-world problem as we can get, because if we're talking about wheelchair ramps, there's a certain height that we can't, or elevation or increase in elevation that they don't want it to surpass, which just makes sense because at least all of us at some point have been in a wheelchair, whether we needed it or not. Just for some reason, I'm not excluding myself, we like to sit in there and just kind of mess with a wheelchair. And as someone used to tell me, that normally leads to some people having to be in a wheelchair, or if you mess with crutches, if you mess with them long enough, you'll end up needing them. But we know that rolling a wheelchair can be difficult. I mean, especially if you're trying to go up a hill. So they're trying to keep it to a point where it's not just going to be incredibly taxing. So the maximum kind of elevation or change in elevation that you can have on a ramp is 1/12. A business and so on, so we could go through this here, and really all it is, well, prices in inches. The change in horizontal is 24, so the change in run is 24 feet. We can convert it all into inches and do 22 divided by 288. Vertical change over the horizontal, which tells us that it's 0.76 inches. 1/12 is 0.083, so it's fine. But there's different things that we can do with this here. And these are just our general form, because general form ax plus by plus c is equal to 0, just the general equation. Standard form normally states it as ax plus by is equal to c, where a, b, and c are all whole numbers, all natural numbers or integers. They can't have fractions or decimals, and a is always positive. B can be negative, C can be negative. A has to be positive, and this is considered standard form of a line. We have the vertical line, x equals a, our horizontal line, y equals b, slope-intercept form, point-slope form, and 2-point form. I mean, none of this is new. None of this is something that you haven't covered before. That's it.